Today, we are diving deep into the hidden language that connects, well, pretty much everything, from your morning coffee to the smartphone you're probably holding. It's the science of stuff, and trust me, by the end of this, you're gonna see it everywhere. So let's jump right in. Okay, just think about that for a second. Your food, your phone, your medicine, on the surface, they seem completely unrelated, right? One keeps you alive, one keeps you connected, and one helps you heal. But believe it or not, there is one powerful science that ties them all together. You guessed it, chemistry. It is the invisible architect behind all of it, and it's so much more than just bubbling potions in some secret lab. It's the science that explains what things are made of, why they act the way they do, and how they can be transformed into something completely different. So here's our game plan. First, we're going to uncover all the chemistry that's hiding in plain sight. Then, we'll crack open the scientist's toolkit and look at the method behind all the madness. After that, we'll gear up for the lab, and finally, we'll cover the super important rules for handling chemicals like a pro. All right, let's get into our first section. I want you to forget that classic image of a sterile lab for a minute. The real chemistry, the important stuff, is happening all around you. In the air you breathe, the food you eat, even inside your own body, like right this second. So what is chemistry, really? Well, at its heart, it's the study of matter, basically all the stuff in the universe, and how it all interacts. But what's really cool is where the name comes from. The word chemistry actually comes from the Arabic alchemia, which is this little nod to the incredible, centuries-long global history of this science. And you don't have to look far to see its impact. You know, the preservatives that keep your food from going bad? That's chemistry. The antibiotics that help you fight off an infection? That's chemistry in action, saving lives. From the fertilizers that help our crops grow to the paint on your walls, we are literally living in a world built by chemistry. And chemistry isn't just about the past, it's pushing us into the future. Scientists are now working at what's called the nanoscale. That's a billionth of a meter. It's so small it's hard to even wrap your head around it. Like, if a marble was 1 nanometer, the entire Earth would only be 1 meter wide. This field, called nanochemistry, is leading to some mind-blowing breakthroughs, like new ways to deliver medicine right to cancer cells, or food packaging that tells you when your food is about to spoil. It's a whole new frontier. So, how do scientists actually make these incredible discoveries? Well, it's not magic, and it's not just luck. There's a method to it. Let's dive into our next section and check out the powerful framework they use to find answers. And this is it, the scientific method. The best part is, you don't need a PhD or a fancy lab coat to use it. It's just a really smart, systematic way of thinking that can help you solve any problem, big or small. You can think of it as the ultimate recipe for discovery. And here's that recipe. It all starts with a simple observation. You just notice something. That leads to an inference, which is kind of your first educated guess about what's going on. From there, you narrow it down and identify the problem. Then you form a testable hypothesis, an if I do this, then that will happen kind of statement. The crucial next step is to identify and control your variables, and then, finally, you get to plan and run your experiment. It's this logical path that takes you from a simple, that's weird, to a genuine discovery. Now, controlling variables is absolutely key. It's what makes an experiment legit. Let's use a simple example: dissolving salt in water. The one thing you decide to change, that's your manipulated variable. Let's say it's the water temperature. The thing you measure to see what happens, that's your responding variable. In this case, it's how much salt dissolves. And everything else, and I mean everything else, like how much water you use, how much salt you add, has to stay exactly the same. Those are your fixed variables. Getting this right is what makes your results actually mean something. Okay, so we know how to think like a scientist. Now let's talk about where all the action happens, the laboratory. And when you step into a lab, one word is more important than any other: safety. And this is a super important question, because the answer has nothing to do with your experiment, your hypothesis, or your chemicals. It's all about preparation. It's about protecting the single most important piece of scientific equipment you have, which is you. And this right here is your suit of armor. We call it PPE, or personal protective equipment. Every single piece has a critical job. Goggles shield your eyes, a lab coat protects your skin and your clothes, gloves protect your hands, a mask protects your lungs from fumes, and closed-toed shoes protect your feet. Every single one is non-negotiable, every single time. And hey, safety goes way beyond just what you wear. The lab itself is designed to protect you. Take the fume chamber, for example. You can think of it like a superpowered ventilation hood. It's designed to suck all the dangerous gases, toxic vapors, and nasty smells away from you so you never breathe them in. It's an absolute must for any experiment that involves combustion or anything that's volatile.
All right, we're suited up, we know our way around the equipment. Now it's time for our final and maybe the most critical section, how to actually manage the chemicals themselves, especially when things go wrong.
Look, even with the best preparation, accidents can happen, but being prepared for them can turn a potential disaster into just a minor managed incident. So let's talk about what to do when there's a chemical spill.
Okay, the general procedure is pretty straightforward. Step 1 is to inform. Don't try to be a hero. Tell your teacher or the lab assistant right away. Step 2, prohibit. Cordon off the area and make sure nobody else wanders into the spill. Step 3, contain. You can use something like sand to build a little border around the spill to stop it from spreading. And finally, Step 4, clean up, but only by following the exact correct procedure for whatever chemical was spilled.
Now, not all spills are created equal. Some are way more dangerous than others, and the mercury spill is a huge deal. What makes mercury so scary is that it's highly volatile. That means it evaporates easily at room temperature, releasing a poisonous vapor that you can't even see or smell.
So, for a mercury spill, the first 2 steps are the same. Inform your teacher and prohibit access. But step 3 is totally different, and it is critical. You need to sprinkle sulfur powder all over the spill. Don't use sand. The sulfur actually reacts with the mercury and makes it way less volatile and much safer to handle. And finally, because mercury is just so hazardous, step 4 is to contact the fire and rescue department. This is a job for the pros.
So let's just quickly recap the big ideas here. Number 1, chemistry isn't just some class you have to take. It is literally everywhere, shaping the world around us. Number 2, the scientific method isn't just for scientists. It's an amazing tool that anyone can use to solve problems. And number 3, and this is the most important one, safety is always the #1 priority. No exceptions.
So we've covered the what, the how, and the how to do it safely. You now have the basic toolkit for thinking like a scientist. So really, the only question left is, what mystery out there are you going to solve first?